All right. So, like I said, this unit that we're going to be moving into, okay, is going to be dealing with circles and the relationships of angles in circles, and also like segments that are inside circles too. We're going to talk, of course, about like a radius. We're going to talk about circumference. We're going to talk about diameters. We're also going to talk about other things though too, like chords, okay, tangents, secants, I think too. We're going to talk about different relationships in the circles too. We're talking about central angles. We're talking about inscribed angles, and those kinds of things as well. All right. But today we're going to be that. So that's kind of dealing more with just like circles in the plane. But today we're focused on circles in the coordinate plane, kind of like graphing circles. Okay. And it's a little bit tricky because it involves some algebra that we haven't been using a whole lot in this class, right? We're going to be doing something called completing the square. Okay, which maybe you've heard of, maybe you haven't. Okay, we're going to need that as a strategy here today. So we'll start out with kind of like a basic understanding of how we can even write the equation of a circle in the coordinate plane. Okay, a circle, right? When you graph that in the coordinate plane, we don't typically graph things like circles in the coordinate plane. Okay, is a circle a function? So if you look at the graph of this circle here in the coordinate plane, is a circle a function? You might be thinking like, ooh, what makes a function a function? Well, yes, Avery? It's not a function, okay? And can you tell us why you know it's not a function?
Because with the circle, since it goes like 360 around,
okay,
that means that there are like two points at the same x coordinate.
Aha. Right. Okay. So remember, one definition we have for what makes a function is that if one x value goes to 2 or more different y values, then the function, or then this relationship is not a function. Okay. So for example, here at a particular x value, I don't know. Let's just say like this x value here, we have a y value down here on our curve, our graph of the circle. We also have a y value up here at that same x value. Okay. That's what Avery is describing, right? We have like a visual way to talk about whether a function is, or something's a function or not. And that's the vertical line test too, right? You guys have probably remember that the most, right? If you can draw a vertical line through your function, you can draw a vertical line through your relationship, and it hits your relationship more than twice, your graph more than once, I should say, more than once, then that relationship is not a function. So like here, for example, if I drew a vertical line, I'm going to hit the circle here and here. This thing's not a function. So, typically we don't graph things that aren't functions in the coordinate plane, right? We just don't have a whole lot of practice with that. And so that's going to make this a little bit uncomfortable for us. But we'll get through it here together. All right, so in the notes here it says you have already worked with circles in several earlier lessons. That's not really our case. We're kind of jumping ahead to this. But anyway, now we'll investigate circles in a coordinate plane and learn how to write an equation of a circle. Okay, we can define a circle as the set of all points in the coordinate plane that are a fixed distance r standing for, exactly, the radius. It's the measure from the center to a point on the circle. So a circle is defined as the set of all of the points in the coordinate plane that are a fixed distance, that is a very particular distance, r, from the center. We'll say the center is at h, k, right? H is the x-coordinate of your center. K is the y-coordinate. Okay. Remember, how do we find the radius? We measure from the center of our circle to a point on the circle, right? And so then how do we make a circle? It's just the set of all of the points that are the same distance from the center, okay? From the center, whatever that radius distance is. Okay, so let's just consider a circle in the coordinate plane that has its center at center C, h, k. So that's how we write the center sometimes as a capital C for the center there. And its center is at hk and has a radius of r. So we're using a very generic kind of description here. So you can see here's our picture, right? In this case, they drew the center of the circle to be at this point hk. It's in the first quadrant. It doesn't have to be in the first quadrant, though. It can be in the second or third or fourth quadrant. We're just going to make it here in the first quadrant just because. Okay? Then you can see that from the center to a point on the circle, we create this r, that's the radius, right? Center to a point on the circle, that length there is the radius r. Maybe I'll even write that there. Okay, that's the radius. Okay? So, let P be any point on the circle, and let the coordinates of P be x comma y. Okay? So we're just going to pick a generic point P that's on the circle, okay? Has x coordinate x, y coordinate y, and it's a distance r from the center, which HK. Okay? It has us create a right triangle by drawing a horizontal line through C and a vertical line through P as shown. So you can see we create this right triangle right here by drawing a horizontal line, and they kind of like, horizontal line through C and then a vertical line through P, and it creates this right triangle right here. Okay? What are the coordinates of point A? What would the coordinates of point A be? Let's talk about what would the x coordinate of point A have to be? Or what letter could we use to describe the x coordinate of point A here? If that's where A is right there, maybe I can zoom in some here. Here's A. What would the x coordinate of that point have to be? Remember that A is horizontally to the right of C and vertically below point P here. So exactly right. It'd be the same x coordinate as P. So in this case, we'll just use the x. Okay. What's the y coordinate for A going to be? Same as C, right? K in this case. Okay. So what are the coordinates for point A? We'll zoom back up here. Okay. What are the coordinates for point A? The coordinates are x, comma, k. Explain how you found the coordinates of A. Well, okay, again, A is below P, so its x coordinate is x, and A is horizontally to the right of C, so its y coordinate is k. Okay? So, next thing we're asked to do is use absolute value to write expressions for the lengths of the legs of triangle CAP. Okay? So, the length of CA, for example. How can we come up with the length of CA here? What could we subtract to get the length of CA? This distance here from C to A. If C has coordinates HK and A has coordinates XK, how can we find this distance here from C to A? What could we do? X minus A, or sorry, X minus H, yes, X minus H. Okay, that's right. All right. What about PA? What would its length be? This vertical distance. Again, they both have coordinates of X, but the y coordinate for P is Y, the y coordinate for A is K. How can we write the length of PA here? What could we do there?
Y minus K.
Y minus K, yeah, Y minus K. So those are the two legs. So according to the Pythagorean theorem then, what can we write? Well, we can write leg squared, x minus h, right? CA is one of the legs. PA is the other leg, y minus k squared. Okay? Equals, what's the hypotenuse? R squared, right? R squared. Radius squared. There's the equation for our circle. X minus h quantity squared plus y minus k quantity squared equals the radius squared. Okay? This is a little bit of a weird equation because we have x's and y's on the same side of the equal sign. Normally, when we talk about graphing, when we talk about writing the equation of a function, normally we have y equals stuck with x. But here, the x and the y are on the same side, and r, which is going to be a number, will be over here. Okay, but this is the way that we have to write the form for the circle. It's not a function, so we won't necessarily be able to solve for y very nicely here. We can solve for y, it's just not so nice. Okay, so compare our work. Well, we did that together, so there's not really a comparison to be made there. Okay. So then, suppose a circle has its center at the origin. What is the equation of the circle in this case? We'll skip 1 and 2. We'll go to this one. Suppose a circle has its center at the origin. That means what are the coordinates of the center? 0, 0. Okay. What did we use as the coordinates for our center for this circle? H and K. So if our if our center is at the origin, H and K will both be what numbers? They're both going to be 0. So that means for a circle centered at the origin, that H right there will be 0, that K right there will be 0. And so what will it be? X minus 0, which is just what? X, and Y minus 0, which is just what? So it'll be X squared plus Y squared equals R squared. Okay? X minus 0 squared plus Y minus 0 squared equals R squared, or X squared plus Y squared equals R squared. Obviously, this is the more preferable one right there. That's for a circle centered at the origin. At the origin. Okay? And so then, here is the equation of a circle, right? We just derived that. The equation of a circle with center h comma k and radius r is x minus h quantity squared plus y minus k quantity squared equals radius squared. Okay? You've seen those h and k's used before. If you remember back in Algebra 1, h and k represented the vertex of a parabola. Does that like ring a bell at all or anything? Yes? Okay. So you talk about, they use the h and k as kind of the typical, two letters that you use for like special points on a graph of something. So for a parabola, h and k is your vertex. Here in this case, h and k are the center of our circle. Stuff like that. So anyway, we also talked about like h and k a little bit when you talk. I also did this a little bit with like absolute value of x, and how you transform that and things too. All the different transformations you guys did. Anyway, so let's look at here an example of what we're going to use this for. Okay, so for example 1, it says to write the equation of the circle with the given center and radius. Okay, so here's an example right here. Center, -2, 5, radius 3. Okay, so that means -2 and 5, that's the center. That means -2 is our h, 5 is our k, radius r is 3. And so you can see here we start with our equation of our circle, x minus h squared plus y minus k squared equals r squared, and you just substitute in. -2 goes in for h, so you get x minus -2, bless you. 5 goes in for k, and then 3 goes in for r. Right there. And then simplify. Minus and negative, we can make that plus positive 2. Y minus 5, we can leave that. Y minus 5, bless you. And then 3 squared is 9. Okay? And there's the equation of our circle. There's the equation of our circle. All right. Let's try letter B here. Okay, in this case, our center is 4, -1. The radius is the square root of 5. Okay, so 4, is that our h or our k? It's the h, right? X coordinate goes to the h, and so -1 is our k, and the radius, root 5, that's r. And so here, replacing the h is a 4. Okay, replacing the k is a -1, and replacing the r is the square root of 5. Okay, so x minus 4 becomes just x minus 4. Y minus -1 becomes what? Y plus 1. And then square root of 5 squared is what? Just 5. It just cancels out, right? A square cancels out a square root. And so there it is. So it's x minus 4 quantity squared. And let me write this out. It might look a little better if I write the whole thing out. X minus 4 squared plus y plus 1 squared equals 5. Okay? Now, if you're curious, you can actually graph this using your graphing calculator. Okay? And I'll show you that here real quick before we jump into some other stuff about finding the center and radius of a circle. Okay. In order to graph something in our graphing calculator, what buttons do we need to press to graph something in our graphing calculator? We got to go to what? If we want to graph something, we have to go to what? Y equals, right? I got some stuff in there from calculus, so I'll clear that out. So in order to graph something in our graphing calculators, we need to have y equals stuff with x. In the current format we have right here, can we type this into our calculator, the way we have it here? No. We need to get y by itself here. Okay? So I kind of will show you how we're going to do that here in just a sec, or right now. So I'll do it down here. We're going to use some algebra here to get the y by itself. Okay? So the first thing I'm going to do to get this y, there's our y, we want to isolate that. I'm going to subtract this quantity over to the other side. So we're going to end up with 5 minus the quantity x minus 4 squared. Okay, right? It was a positive x minus 4. So if I subtract x minus 4 squared from both sides, we end up with this. 5 minus quantity x minus 4 squared. Okay. And now at this point, how should we proceed? What should be our next step here to start getting the y by itself? Avery?
How to do 1 plus 1 squared and x minus 4 squared.
So I see you want to actually distribute those out and stuff like that.
Yeah.
So actually we don't need to do that here. Let me show you here. Actually, because we can just do this. We can actually just go ahead and square root both sides. It's going to look a little messy. That's okay. When you square root a square, it cancels out. You're left with y plus 1 equals, and then here, this square root's not going to simplify. We're going to put a plus or minus, because in this equation setting, we need to put that plus or minus in front there. Okay, like that. Okay, so again, all we did was a square root the square there to get us the y plus 1 by itself. And then what's our final step here to get the y by itself? Yeah, just subtract 1. So we get y equals negative 1 plus or minus the square root of 5 minus the quantity x minus 4 squared. Okay? And that is solved for y. So we can now graph this in our graphing calculators. All right? So to do that, let's see if I can get this. Actually, let me do this. Just tear the page up. Let me show you here real quick. Okay. Here's how we can graph this circle now in our graphing calculators. All right. We're going to go to, whoops, go up to y1 here. We'll type in negative 1. Now, plus or minus, we can't do plus or minus. There is no plus or minus command in our calculator. Actually, there might be, but it doesn't quite graph the way we want it to. So we're just going to make it, we're going to graph 2 graphs. We're going to graph negative 1 plus the square root of 5 minus the quantity x minus 4 squared. Whoops, I missed an x. Okay. So negative 1 plus the square root of 5 minus x minus 4 squared. Okay, like that. And then we'll do negative 1 minus the square root of 5 minus x minus 4 quantity squared. So there's how we're going to graph the plus or minus. We're just going to graph them both individually, though. One as the plus version, one as the minus version. If we then go to our graph here, okay, let me do zoom standard, sorry. Okay, there's our circle. And it doesn't look that great. And the reason why it looks more like a football is because of the way our screen is here. If you'll notice that our screen is not a perfect square, it's a rectangle. But when you use the standard viewing window here, we go from negative 10 to 10 this way and negative 10 to 10 this way. So the negative 10 to 10 here is squished down as compared to the negative 10 to 10 here because it's wider, right? It's wider here to go from negative 10 to 10, so it stretches things out. And the negative 10 to 10 here is narrower, so it squishes things down. To fix that, if you press the zoom button, and go to number 5, zoom square. Okay, you can see it kind of fixes the circle there. Okay, or it fixes the graph so the circle looks more circular. Again, part of the issue here as well is the graphing calculator won't finish graphing the whole circle and it's just because it's just an error on the graphing calculator's part. It just doesn't, quite fill in the whole circle there. But there it is. That is the circle. Okay, so you can kind of see it graphed there, okay, in the coordinate plane. Is the center correct? Well, we need a center of 4, -1. So if I go right, 1, 2, 3, 4, and down 1, that does look like it's the center of the circle there, doesn't it? Okay, so anyway, there's the idea. 4, -1, and the radius of square root of 5. That's hard to count then. Okay, but 1, 2, 3, 4, and then down 1, so there's our center. Okay. Questions on any of that? On the graphing part? So that's just something I wanted to show you there. You can graph it with the graphing calculator. All right. Let's turn the page then to the next section, and I'll have you guys go ahead, write the equation of those two circles, numbers 5 and 6 for the your turn at the top of the page there. So you guys go ahead and try 5 and 6. Okay. Again, remember the equation for the circle, x minus h squared plus y minus k squared equals radius squared. And just write the equation. You don't have to solve it for y if you don't want to. In fact, I recommend not doing that. What's up, Preston? Oh, you got your plot 1 on there, so if I go up and hit enter, it turns it off. It's applicable, but if we change our try to zoom 6 there. Okay, if I do, so that's just the standard view. But if I do zoom square, it's more of a circular kind of nature of it. Okay. Yep. So again, give those a try. Give those a try there. All right. There's 1 and 2. Do not have your. Okay, that's fine. That's fine. I just want to make sure. Okay, you guys don't have your books on. Rich, doing okay with everything so far? Yeah. Okay. Grace, doing all right? No? Okay. So, center is 4, 3. All right. So that means in our equation of the circle up there, what will h be? What number do you want for h? Well, what is the x coordinate of our center? 4. So, h is the x coordinate of the circle, so you just replace the h with the x. And then the k, what goes in for k, you think? Yeah. And then the radius will be 4, so it's be 4 squared. Okay, and then you try the next one. That's great. The only other additional step I could say, so don't forget the square with the y plus 3, so y plus k squared. And then you could just make that 16 if you wanted to, and same thing, you can square the square root of 3.
Okay.
But that's the only additional step I would say that you need to do. Good job. Looking good, looking good. Okay. Really glad to see a lot of people for number 6 are changing the minus and negatives to plus positives, right? So I'm glad to see that. That's good for the simplifications and things. That is good. Aubrey, you want to give us the answer here for number 5, or what did you come up with?
Just like read mine.
Yeah, please.
X minus 4 squared plus y plus 3 squared equals 16.
Y
Oh,
minus 3.
minus 3, yeah.
Okay, equals 16. Sounds good. Okay, good job there. Questions on number 3? Good. All right. And then let's go to, oh, Jenny, your number's up again here, Jenny. How about number 6 there, Jenny? What'd you get?
I said that x plus 1 squared plus y plus 1 square root of 3 squared.
Equals, sorry?
The square root of, or
Square root of 3 squared. And what happens when you square a square root?
3.
Just 3. Very good. Okay, so yeah, there are your answers. Okay, not too shabby, right? Not too shabby. All right, not too bad. Any questions on that before we move on? Because the next part is going to be a little algebra intense. Okay, so here's where the real meat of what we're working on today is going to be located. Okay, so sometimes you may find an equation of a circle in a different form. In that case, you may need to rewrite the equation to determine the circle's center and radius. You can use the process of completing the square to do so. Okay, so does anyone recall even hearing the words, the phrase, completing the square from Algebra 1? Yes? Okay, yes, a few of us? Okay, good. And do you also remember how confusing and awful it was? Yes, okay, we definitely remember that part, right? So, it is a tricky technique. Okay, so let me kind of like give you a little bit of a background into it, maybe to help give you just a little bit more push. Sometimes some things in math, I feel like the only way they come easier is to see them over and over again, and to just get the practice with it. Okay, and this is one of those cases potentially. All right, so completing the square is a strategy that we use to factor polynomials. Okay. So you remember we talked about like factoring quadratics and stuff like that, like very briefly, here and there kind of deal, and when it comes to when I say factoring quadratic, those are things with the form like x squared plus, I guess ax squared plus bx plus c, okay? Factoring these kinds of things, right, where you break it up into two binomials, where you have, something x plus something, and then something x plus something else, and you multiply that. That's factoring, right? To take this and break it up into two binomials, that's factoring, and then if you FOIL these back together, right? If you multiply these back together, it should result back in that quadratic. All right. And you have strategies for going from this quadratic equation to this factored version, right? Some factors you would like maybe look to see, okay, what are two numbers that multiply to c but add to b? That's if your a is like 1, okay? You'd like look at that. Sometimes you use greatest common factor. That's a strategy, where you pull out the biggest thing there, and that helps too. Sometimes you would solve this using the quadratic formula, right? Sometimes it just doesn't factor. So it's equal to 0. You could just use quadratic formula to solve it and stuff like that. But you would also use the strategy of completing the square to take this quadratic, which may not be a perfect square. It may not be a perfect square, right? In order for something to be a perfect square, that means it needs to have one thing that you multiply by itself to give you, this. Most of the time when you factor a quadratic, right, you don't multiply something by itself. You multiply two different things together to get your quadratic equation. But when you complete the square, you create a scenario where you make it a perfect square. You complete the square. So right now, this thing might not be a perfect square. You're going to complete the square, and that allows you to then factor it to a perfect square. Okay. So let me show you how we're going to do that here. And I know it's going to kind of run through it here, but I don't want to use their words. I'm just going to do it right here real quick. Okay, so let's say we've got x squared minus 4x plus y squared plus 2y equals 20. Okay. Hopefully you can recognize here, right, this is not in our typical x minus h quantity squared plus y minus k quantity squared equals r squared. That's not the right format, right? Only x is being squared here, bless you, and we have a minus 4x, and only y is being squared, and we have a plus 2y, which is strange here because we don't have any, of that. It should be x minus a number quantity squared plus y minus a number quantity squared equals radius squared. And that might be the radius, but probably not because this isn't in the right format on this side. So how do we fix this thing? Well, we're going to take our x squared minus 4x, okay, and we're going to put another number right in here. We're going to make it a perfect square. And then we're going to take our y squared plus 2y, and we're going to put another number in here, and it's still going to be equal to 20. So what numbers are missing in those blank right there, right? What numbers would make these things perfect squares? Well, it's kind of hard to say, but let's take a look here. If I wanted this thing to be a perfect square, I'm going to need this thing, this quadratic here, to factor so that I have an x and an x. I'm going to come up with some numbers here. And then same thing here. I want this to factor so that I have a y and a y. Again, it's going to equal to 20. Okay. Well, right now, with the x and the x, that's going to give me an x squared. But I also need these two numbers to add to make negative 4, right? What two numbers add to make negative 4? Negative 2, right? Negative 2 and negative 2. Those aren't the only numbers that add to make negative 4, though. What else adds to make negative 4? Negative 4 and 0. Okay, right. But why do we want to use the negative 2 and the negative 2? Well, because if I use negative 4 and 0 here, would this thing now be a perfect square? Would I be multiplying something by itself here if I put a negative 4 here and a 0 here? It wouldn't be the exact same thing, right? I need the same thing. And so what I'm going to pick, I'm going to pick, like Jackson said, the minus 2 and the minus 2. Okay? So that creates a perfect square, right? X minus 2 times x minus 2 is x minus 2 quantity squared, isn't it? Well, I'm going to have the minus 4x already, right? Minus 2x, and then the other minus 2x is right there. That creates minus 4x. But what else will the minus 2 and the minus 2 create right here? What do I need right here? What number is going to have to go there for this negative 2 and this negative 2 here to exist? What number needs to go here? Well, when we FOIL this out, right, it's x times x, x squared, negative 2x, and a negative 2x creates that negative 4x. But then the last, negative 2 times negative 2 becomes what? A 4. We need a 4 here. So we have to bring in a 4 from out of nowhere. Okay? We're just going to throw in a 4 onto our equation here. But if I bring a 4 into this left-hand side of the equation, how can I balance that out? I can't just bring a number in out of nowhere. What do I got to do with this plus 4 here? We have to add a 4 to this other side too. Okay. So now let's look here. All right, y squared plus 2y, and I have a blank. Again, I got to figure out this missing number here. Well, let's go down to here. To get a y squared, I need a y times a y. What can I do to make a 2y, though? What two numbers here are going to add up to make 2y? 1 and 1. Okay? 1 and 1. That is going to add, so it'll be 1y plus another 1y makes 2y. And again, why do we pick the same number? Why was it important that Madison picked the same number there? Because we want it to be a perfect square. Y plus 1 times y plus 1 is y plus 1 squared. We still have a plus between those two things. So if I were to, again, multiply this out, y times y is y squared. 1 times y gives us 2y. What's this last term going to be, though? 1 times 1, 1. And so if I put a plus 1 here, I got to add 1 over here to this side too. Okay? Again, I'm bringing in this plus 1 from out of nowhere so that to make this thing so that it factors to y plus 1 times y plus 1, which is y plus 1 squared. I put the 1 over there. So this thing's not 20 anymore, it's now 25. Okay? And so let's take a look at this now. What is the center of our circle? The equation there. What's the center of our circle? What's the x-coordinate for the center? Careful. 2, and then negative 1. And the radius will be what? Careful. Remember that it's the radius squared when we have the equation. So if that's the radius squared, what's the radius? 5. And there's the center and radius for our circle. Okay, if you look here, we can see, Here's the solution graphed. Okay, here's the center, 1, 2, and then down 1. There's our center of 2, -1. And let's just count our radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it goes 5 in each of the directions there. And of course, all the diagonal directions are 5 too. It's just harder to count that in the coordinate plane. And so there's our circle. Okay, so let me go back through this once more here real quick. We'll try another one too. All right, so we had an equation of a circle, but not in the typical form that we wanted. So we had to complete the square, both for the x's and for the y's. Okay? And then that number 4, that number 1, we had to add to this side as well to balance out the equation, because we brought that 4 and 1 in from nowhere. So if we add 4 to this side, we've got to add 4 to this side. We add 1 to this side, we've got to add 1 to this side. Okay? This then factors. And this then factors to perfect squares. We're left with the 25 here, so the radius is going to be 5, and then the center is 2, -1. Okay. All right. So there's that. Let's try another one, though. All right, so let's turn the page here to letter B. Again, I don't want to use their blanks because I don't really like their blanks too much, so we'll just do this letter B here together. Okay, so x squared plus 6x. Okay, we'll leave some space. Plus y squared minus 4y. Leave some space. And that plus 4, I'm going to go ahead and move that over to the other side. I'm going to make that equals -4. Okay, so move that plus 4 over to the other side. Make it -4 there. So again, our goal is to factor these x's, so we have x times x, and then same thing with the y's. We want a y times a y there. Okay. So what two numbers do we want to put in here so we end up with a 6x? And then if you do the same number, what two numbers here will make that 6x there? 3 and 3. Right? Well, that creates that perfect square of x plus 3 quantity squared. Okay. If I make that 3 and that 3, that means what does this number have to be right here? A 9, right? Because it's the last. 3 times 3 makes 9, so plus 9. If I add 9 here, I've got to add 9 to this side as well. Okay. Let's look here at the y's. If I need a minus 4y for my middle term, what two numbers are going to have to go here and here? -2 and -2, exactly right. Again, they need to be the same. There's many options, right? There's many ways to add to make -4, but these need to be the same because we're trying to make a perfect square here. We're trying to complete the square, make it a perfect square. And so if I put in a -2 and a -2, that means I'm going to put in a plus 4 here. So I'm going to add 4 here too. And so this actually ends up being 9. Okay. And so what's the center of our circle? What are the coordinates for the center of our circle? -3, +2, and the radius is? 3. Okay, and we can graph that right over here. -3, 1, 2, 3, 2, 1, 2. And then radius of 3. So I'm going to count 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, 1, 2, 3 down. I'm just going to freehand the rest. If you want, you can use a compass. I'll provide compasses for y'all. If you like. Okay, my ugly circle later. Questions on any of that? Okay, this is not easy. Okay, this is not easy, right? Or if you think it's easy, great, good. But for those of you that are having trouble, you're like, this is hard, I don't understand any of this. I understand, it is tricky, okay, but you can get it down. You can. Okay, we'll do one more here together, and then I think, well, 1 or 2 more here together, maybe. We'll do 2 more. We'll do the 8 and the 9, and then we'll stop there, I think. That's all we have to worry about. Yeah, we'll maybe look at the next one. Yeah, okay, anywho. All right, number 8. let's again complete this square here. All right, so we'll set it up, x squared plus 2x, and then a blank plus y squared minus 8y, and then a blank. I'm going to move that 13 over, make it equal to negative 13, like that. Okay. So again, I'm looking for this. I need an x here, plus, and then a y here, and a y here, equals, well, not negative 13. We'll wait for that. Okay. So again, we want to factor this thing to be a perfect square. So we're going to have an x times an x. What two numbers do we need to put here and here to make that 2? 1, right? Yeah, they both can be 1. And then a 1 times a 1, that's going to mean we'll have a plus 1 there, and so we'll have a plus 1 over here. Okay? What about negative 8? What two numbers can we use to make negative 8? Yeah, negative 4, negative 4. And so that means what's going to go in this blank right here? Well, the negative 4 times negative 4 is going to make what? 16, and so we'll have to add a 16 over here too, okay, to balance it out. Okay, so then this is x plus 1 quantity squared plus y minus 4 quantity squared equals negative 13 plus 16 is 3 plus 1 is 4. Okay, so what's the center of our circle? Negative 1, 4, and what's the radius? 2. So we can plot that point. Negative 1, 1, 2, 3, 4. Radius of 2, right 2, up 2, left 2, down 2. Just again, freehand the circle there as best you can. Something like that. All right, questions on any of that? All right, we'll do number 9 once more here, and then we'll take a look at number 9 now. So let's see here, number 9, there's just x squared. There's no number with the x there. So x, that's already a perfect square. It's x squared plus, and then we have to do y squared plus 4y blank equals then the 5 there. So the x is already a perfect square. There's no more work we need to do there. If you want, you could put like an x minus 0, square. That's fine, but it's already a perfect square. X is already a perfect square. Okay. Here we have to figure out though for the y's. What two numbers have to go in here to make that positive 4? 2 and 2. 2 times 2 is going to be a plus 4 there, and that's going to make a plus 4 over here too. And so this isn't 5, really it's 9. And so we have x minus 0 squared plus y plus 2 squared equals 9. What's the center of our circle? Zero, negative 2, good. 0 for the x-coordinate, negative 2 for the y-coordinate. And then what's our radius? 3, yeah. 9 is our radius squared, so radius will be 3. And so 0, negative 2. Radius is 3, so 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And there's our circle. Okay. And actually, I think we'll hold off on going on to the next one here. I think that's going to be too much. So we'll stop there. We'll stop there. I think that's enough for today, okay, just because it's a little intense material, all right? So for your assignment, okay, it'll be in the book here. Starting on page 896. Starting on page 896. Numbers 2 through 9. And 14 through 16. Nine, 1923, yeah. Okay. 1923, those are all true falses, okay? But do be prepared to explain why something's false. Okay? Be prepared to explain why something's false. Okay? So there is your assignment.